when electricity flows through a power cable like this one, the electrons, the individual particles of electricity, they constantly bump into the atoms that are in this cable. And because of that, if you want to charge your phone with it, you have to constantly keep pushing these electrons through the cable because they slow down because of all these collisions. So this pushing costs a lot of extra energy. And a superconductor is a material where the electrons just flow without any resistance through the material. Because of these properties, we can use superconductors for all sorts of applications. Not only would they make energy transport much more cheaper and more efficient, but also used in all sorts of high technological electronics. The way this superconductor works is very strange, actually. So normally, the electrons in these materials, they all repel each other. But here, the two electrons that move with the same velocity, they can form what is called a Cooper pair. And this Cooper pair behaves much more like a wave than a particle. And because it behaves like a wave, it can just flow through the material without colliding with any of the individual atoms. It just flows around them. Now, the downside is that these Cooper pairs become unstable when they warm up to more than minus 240 degrees Celsius. So this means that we have to cool down these superconductors to incredibly low temperatures if we want to be able to use them at all. In 1986, two researchers discovered a mysterious material that still behaves like a superconductor, but at minus 160 degrees Celsius. It's still very cold, but this is 100 degrees above what we thought was the theoretical maximum limit for these things to exist. And they had no idea how this was possible, and they called this a high-temperature superconductor. Now, we've been studying these high-temperature superconductors for 30 years by now, and an important difference that we found out about is that in these mysterious materials, all the electrons seem to interact incredibly strongly with each other. So it's not just that two electrons seem to form a Cooper pair, but it's almost all of them that seem to cooperate in some way that they can flow through the material again without any resistance. So what then don't we understand about it? And what we don't understand about it is the math, because it's incredibly hard to solve these equations that describe millions of interacting electrons that all flow through this material. So we can find new materials like this in a lab, but finding out why one of these is superconducting from first principles, calculating that, is nearly impossible. So by studying the math behind this, we hope to be able to properly understand this, and in the future maybe even design new superconductors that are still superconducting at room temperature, and maybe can even be used in power cables.